unscreen share.
If you're not muted, now's a good time. Except for Brad.
Okay. I trust folks can hear me. All right. So I'm going to talk about getting the ESP32 talking to Gemini. My goal with this project was to make an ESP32 talk to Gemini using Forth. And slide this down because I can't see. Oops. Okay. So the Forth that I'm going to use is ESP32Forth, which is also known as Micro eForth when it's not running on an ESP32. It's a C implementation of Forth that leverages a technique called X macros to build the system in a very simple way. It has sort of 4 big opcodes that are multi-line chunks of C code, and then almost everything else is that's in C is 1-line opcodes, and then everything else bootstraps from Forth code that sits in a string. This makes it buildable as a single .ino file in Arduino, where it looks, like a big chunk of Forth code. I recently started to fission it apart into some optional modules. Gemini, for those folks who are unfamiliar, is Google's AI chatbot. It's a multimodal large language model, and it has a cool API that lets you talk to it across the internet. ESP32, really briefly, is this family of devices from ESP32 Systems. It has a lot of features. The key one for me, though, is that it has Wi-Fi, so it can talk to the network. It has various different, depending on the model, approximately 512K of RAM, and then at least 4 megs of flash. Some of them have more. There's a bunch of different variations. Most of them use the Tensilica Extensa instruction set. In variations, a few of them use RISC-V5, which is also, move this up out of the way. Get that to go away. Okay. That's even worse. This is what one of them looks like. The particular device that I'm going to be demoing on is picked not because it's my favorite, but because it's the most portable. How do I get that to go away?
Just hit that up there, the arrow that's below the window.
It's a T-dongle S3, which has an ESP32 S3 on it. It has a little screen. The reason I don't particularly recommend it is that although it works generally pretty well, 2 problems. One, it gets wicked hot when you plug it into a USB port, alarmingly hot. The other is that after going in and out of a device a bunch, it quickly fell apart. So I had to super glue it together. But it's nice and portable, so it is what it is.
Did you run out of duct tape?
Well, anywho. One key thing with it, by the way, is that it has a slot for an SD card, so you can pull the SD card out, stick that in the PC, transfer files, and then stick it back in the lip of the dongle, which is nice. So the goal here is to take an ESP32, talk across the internet over HTTPS. This is going to involve some JSON to talk to the Gemini API. We're going to have to talk HTTPS. This is the encrypted protocol that folks use to talk over the internet. It's a wrapper, the TSL layer around a TCP connection, or this used to be called a secure socket layer. It encrypts the connection with a symmetric cipher. Usually it's AES. That's good enough to hide your communication, but you also need to establish a chain of trust to know that you're talking to the right party, so you can't be man in the middle. For this, RSA or elliptic curve Diffie-Hellman are used. It's resistant to man in the middle attacks, and but the key thing is that there's a whole process you need to follow in order to establish that you're talking to the right party, because you need a signed certificate that tells you who you're talking to. I'm not going to implement all the crypto myself, so I used a library called HTTP Client, and I added this in as an optional module to ESP32Forth. It supports HTTP, HTTPS. It seems to check chain of trust. You have to watch out for these things. There's a long, sad history of libraries for talking HTTPS that don't bother to check the chain of trust, and then they can be man in the middle. It handles HTTP headers, streaming connections, and connection reuse. And it is now available on the live version of ESP32Forth. One of the things about ESP32Forth that makes it easy to expand is that X macros let you have these fairly pithy one-line definitions. The way they look is a little bit awkward, but it's very flexible. The most general form is you can have this XV macro that you specify a vocabulary, a name inside of a string, and then you have to have an alternate C name and then an action. But there are more abbreviated forms that are more compact. And then you manipulate the state of the virtual machine using a bunch of numbered values that reference the different depths within the stack. Or there's a few macros for manipulating the depth of the stack with either a drop or a nip, which ends up being useful. So the HTTP client library has the notion that you first want to set up what your certificate bundle is. So you need to create an object of that type, of the network client secure type, to hold the bundle of certificates. And you need to set up a word to create one, delete one, and then set a certificate on one with a null terminated string. The bindings look something like this using those macros that I mentioned. And so it's not bad to add in. I'm not going to show the bindings for some of these other methods. What do you pass in? So when you're relying on your web browser to talk to the internet, your browser comes with a bunch of certificates pre-installed on it. And that's curated by the browser makers. You'd be shocked how many there are out of the box, unfortunately. It's sort of a long-standing question as to which ones should be in or out. But for the purposes of a device, I only care about the one root certificate that corresponds to the great-great-granddaddy of the service that I want to talk to. So you can use the OpenSSL tool to look at the chain of trust for a given site and look at the series of certificates that go by. The one that we want is the one down here at the bottom that tells you this is the certificate that we trust. It's a Google certificate that was signed by GlobalSign, and that's what it looks like. It's in a packed format, and that's what you would actually pass into the API. Then you need to be able to set up an object for the network connections. You need to be able to allocate them. Begin a connection, giving a URL that's also a null terminated string. There's a bunch of options for setting whether you want the connection to be reusable, or set your user agent if you want to specify things like that, or the number of redirect hops that will be supported. And then you get down to business and actually want to do a get or a post or a more general send request. And then you get back your result as either a string or as a stream. And the stream is actually kind of handy because then you can get things chunk at a time. You get this stream object that you can get the number of available bytes, and you can read from it. I should flag with all of these words, I've given them shockingly verbose names. This is a pattern I've slid into with a lot of the external libraries with ESP32Forth. They're actually squirreled away inside of their own vocabulary, so maybe this is not necessary, but I've also found that I've ended up confusing myself if I don't have the prefixes, so it is what it is. The great thing is that you typically use them to define other words in Forth and then don't see them again. So that gives us HTTPS. Now we got to have JavaScript JSON objects. And this is a notation that is used for sending messages for all sorts of purposes. Amazon, I guess, uses it even internally for message sending. A lot of public APIs use it. And it's basically a subset of the JavaScript language that is really just about data. And it represents simple types. There's a float64, which has the nice property that it can also represent any of the 32-bit integers exactly. It supports strings, booleans. There's a value for null. And then the way that you build things up into a more complex types is you either have arrays with arbitrary numbers of items in them, or you have what are called either objects or dictionaries, where you have a set of key value pairs. And so arrays are in brackets, and you have curly braces for objects. It's a nice protocol for sending messages because it's human readable. I think that's one of the reasons it's as popular as it is for APIs, because you can kind of look at the messages and understand them readily. It's even given that, it's reasonably compact, and unlike some other formats like protocol buffers or things like that, it's self-describing. So you look at what it is, and it is what it says on the tin. So there's no schema that you have to know about other than sort of the implicit schema. This is what it looks like. Sorry for the folks in the room, it's clipped off on top, but I think on the Zoom you can see it. You can have a series of keys, you can have nested structure, you can sort of do arbitrary things with it. So, but in Forth, how are we going to deal with this in Forth? So we need a way to represent nested structures. It doesn't need to support cycles. JSON isn't allowed to have cyclic references, so it can be reference counted. And Forth lets us build new types and stacks. And for those that saw my most recent talk, I've also been pondering things like APL and Cozy. So could I do something in a style that is borrowed from that world here? So for this particular problem, at least, I think maybe all you need is an array-like structure, a dynamic array. And the idea here is that as long as you have a representation that can support the types that you need, you can have an array of dense values that let you do interesting operations on them. You can compose them and combine them and do fun things. Dictionaries will be a bit of a challenge. I'll talk about that in a second. So first off, we'll need some. I would like to have a separate stack for them because I don't want to have them on the conventional stacks. It'll be super confusing. Creating a stack is not a big deal in Forth. You can have additional ones. So here I've got, I'm calling it the A stack for array, and there's an A push and an A pop. I've got a secondary stack, which I confusingly use to A and from A, which I probably will live to regret. And so then the question, so those are just taking raw individual single cell sized values, and they let you push them and pull them from the stack. So then the question is, what actually goes in the stack? And the pattern that I've cribbed from Cozy actually is that I want to have a type, a single type array where I have the type indicated in one cell, the size, a reference count, and then I have the data in whatever type. And so for each type, it's uniform within that particular array. So if it's an array of characters and is a string, it's all characters. If it's an integer, it's an array of integers. If it's a floating point value, it's floats. Little caveat here. On ESP32Forth, because the ESP32 has hardware 32-bit floating point, but not 64-bit floating point, there's this weird quirk where there is no support for 64-bit doubles in ESP32Forth, so I am just using 32-bit floats. And then critically, to make JSON possible, you can also have a mixed array type where you have an array of arrays, and that's how we'll build up the structure of JSON inside of this. So we can represent this reasonably easily. We can have an enumerated list of values for the type tags. We can have a little table that we build up for how big each of them are, and this e-size word to tell us how big a given type is. We can then have a bunch of convenience words for accessing these items in the header. I should point out that although I'm allocating these from the front here, obviously, the pointers that I pass around, actually, I have them pointing at the data, just because that's typically the thing you want to access, and I've stuck the header information off to the left. You can then, from this, build up words like bytes that tell you how many bytes are in a given array, so that you can do things like know how to allocate it. And you can also convert from an array to a range that will tell you the first element and then the count as to how many of them. And I've got this word array that takes a count, a type, and then allocates it and pushes it onto the array stack. So you're able to say things like 10 integer array and get a 10 integer array on your array stack. Then you got to manage the reference counts. So I have the word ref that just increments the reference count in this reference counted array. And then unref is a little trickier because it has to recursively go through and determine, okay, am I looking at a mixed array? If I'm looking at a mixed array, I go through and recursively free each of the children whenever the reference count drops down to 0. On top of those, you can build stack manipulation words. So I have a whole slew of A-prefixed words that do the same thing with the A stack that they do on a conventional Forth stack in terms of swaps and over and to-dupe and so on. To index into an array is straightforward. I do need to be careful that whatever I pull out, I add 1 to the reference count, but I have this A@ word, which will look at the item on top of the stack, take a index off of the data stack, and that will put a new value replacing the item on top of the primary stack. I have a bunch of words for allocating arrays, so I can create an empty mixed array. I can box up or wrap an array inside of another mixed one. I can create, this is lifted straight from Cozy style, underscore to convert from strings or characters or integers or floats. And then I also have a syntax for a constant string. I can define array constants where I take a value off the array stack and then I stash it away, and then every time the word the constant is executed, I increment the reference and put the value back on the array stack. And then using this, I can have double brackets build up on the data or on the array stack a series of values, and then transform those into a new boxed value. So I can have a syntax where I do bracket and then put a bunch of items and then a closed double bracket, and that will give me an array of that type. There's some conversions that can happen. There's a sort of a direction where this could go to do more APL-like things with type conversion, but none of this is relevant to the JSON stuff. And then to give you a sense, to print one of these structures, here is this word list or LST that will recursively walk the structure and print it and will indent it in a pretty format. And I've also given that the short name of A dot when you're doing it directly from the array stack. The only other operation I actually need for JSON, if I was doing numerical APL-y things, I would need obviously more operations. But for JSON, I just need to glue these things together. So I need the word catnate. So catnate will take 2 arrays and slam them together. It does take some extra care around the situation where you mix the data types of different arrays. And that's enough for JSON. So how do we parse JSON? We're 2 minutes. All right. We've got to have a recursive descent parser, and I'm going to elide the details. But basically what you can do is you can build a recursive descent parser directly in Forth. You can do things like take a value and you can then define the dispatch for it and parse each of the characters. Same thing if you're looking for white space, same thing if you're looking for objects, same things if you're looking for strings, and so on. The net result is that I'm able to parse JSON onto this array stack. Printing is similarly straightforward. Dictionaries, all I do for dictionaries is I stick a sentinel value of a special string called dictionary at the front, and that lets me create a dictionary with a set of words like this. And then I have this dict@ word that lets me go fish a value out of a dictionary. So now the Gemini API, really quick, is a REST API. You send it JSON, you get back JSON, and there's all sorts of features that we don't have time to talk about here, but basically you can ask it for all sorts of things. You posted a piece of JSON telling it something like write a story about a magic backpack, you post it to a given URL, and then it gives you back a big chunk of JSON that you have to pull the result out of. There's a bunch of features like parts we're not going to talk about. I'm going to skip ahead here. You need to set up API keys to make this all work. And then what I've built up is the ability to ask a word and parse the result. And in light of this, I'm going to skip to the demo. So I'm going to stick in this stick, and I'm unfortunately going to unplug the camera in the room and boot up this device.
What could possibly go wrong?
What could possibly go wrong? Internet connection here at Stanford, I'm going to use a hotspot on the phone just because that was a thing I could pre-test. So here I am in this, let me actually share.
We've got the slides double, okay.
There we go.
We're on top of
All right, so I'm going to share this screen.
We see that.
Yep, and so here I've got a block that does a couple things. It relinquishes some memory because you actually need more memory to go to the C heap for this. I sign into this hotspot using login, and then I load my code for talking to Gemini. So I'm going to go ahead and load this, and moment of truth here, if it can connect to the hotspot. Come on, come on, come on. Okay, so it's connected to the hotspot. That's great. And so I'm going to add some of these vocabularies that I've got. I've got one for Gemini, I've got one for JSON, and I've got one for arrays. And what I'm going to show here, first of all, is I've got a word called ask that is, I can put it'll parse the rest of the line and then send that over as a query. So what is forth? Let's ask Gemini that. And it will go, and I've got the debugging turned on, which is why we're getting all this other stuff. There's some debugging results that oh my gosh, that's nice. What is forth? That doesn't bode well. Demo fail. Let's try again. Come on, come on. And I'm getting an error. Okay, we're getting demo fail right now. Let's try a slight. So there's a different word that I have that is designed to allow you to ask for a list of values based on a query, and it will send a query to Gemini and ask for the result in a structured form. So you get back an array of strings for it. So I'll say, let's ask for the primary. What are the primary colors? And let's ask for a list, and let's print that list. And I have a sneaking. Okay, that worked. So it gave me back a list with red, yellow, and blue. And we could also do something similar where we say, who are the kings of England? And I will go ahead and put that inside of a constant called foo. And that didn't do the right. Sorry, that didn't. That put that in foo. So we'll put foo in there, and we'll ask. We'll do ask list, and we'll put the result of that inside of bar, which will go fire off a query, get back the result, and we can print out. Whoa, that's weird.
That's so cool.
That did not work. Oh, because I used the wrong printing. There we go.
How would you feel about revisiting this, like maybe after lunch?
I will indeed do so, but in any event, that is the end of the demo, and if there are any questions.
Hey, Brad, can you drag that control bar off?
The question I have is, Reno?
Yeah.
You're up. Brad, mute yourself.
All right, I will do so.
I think I may need help.
Yeah.
But,
That's why Brad's here.
Okay, yeah, so you should connect over there. I'll put the camera back on here.
Are you on the conference?
And I guess my video too. Oh.
You gotta turn the audio on the room all over.
Ye-